Hello everybody, I will start my today's another live coding session. So in my today's video, I will solve this question, burst balloons. So for this question, I was requested by one of my viewers to solve this question. And I solved this by myself yesterday, but I actually couldn't solve. So I read the editorial and I'm quite convinced. So yeah, this is a kind of typical competitive programming question pattern. So what I mean to say is I have to optimize the time complexity of the dynamic programming. Yeah. So I actually could solve this question with 2 to the power of n um, approach, but I had to optimize it. And the optimization is something hard. Yeah. So that being said, let me get started. So in this question, I'm giving n balloons indexed from 0 to n minus 1. Each balloon is painted with a number on it, represented by an array, nums. Okay. You are asked to burst all the balloons. If you burst the ice balloon, you will get nums I minus 1 times nums I plus 1 coins. So the number of coins that you will get is that number, the number on the balloon which was burst, and two adjacent balloons. I will calculate the product of all the numbers of them on these 3 balloons, and that's the number of coins I will get. And if I minus 1 or I plus 1 goes out of the bounds of the array, then treat it as if there is a balloon with 1 painted on it. Okay. And my task is to return the maximum coins I can collect by bursting the balloons wisely. Good. So I will think of all the possible way and permutation of bursting the balloons, and finally, yeah. Oh, and for each, I will calculate the total number of coins I will get. Then in send, I will return the maximum number of coins in the best permutation. Yeah, so that's what I will do. Okay, so as usual, let me understand this question a bit more. Yeah, in detail. So in this question, the input should be the array of nums. So number is, yeah, not necessarily an integer, I think. No. So array of numbers, yeah. So this represents the numbers of the balloons. And for output, this should be number 2. So this is the maximum number of coins I can get. Good. Okay. And I will think of some edge cases. So if nums array is empty, but as the constraint says, it's not true. So I have at least one balloon. Yeah. So something like this. And also for the number on the balloons is 0 or larger. 0 positive. Yeah. So that's something interesting. Or just say that's something a bit important to me because, for example, having the negative number not may affects the logic. So let's think. I have something like this, and I have something like this. Oh, sorry. Let me say. I will compare this, and when I burst the balloon number 2, here I will get -1 times 2 times 3, which is -6. Sorry. And for here, I get -1 times 2 times 3, is negative 60. Yeah. So what I can find from here is that actually negative 1 is larger than, oh, so let me change it. Let's say negative 3 and negative 3. In this case, yeah. So what I can say is, even though negative 1 here is larger than negative 10, in total, I get less coin with negative 1 because there's another negative number here and another negative number here. So I have to take care if number in the balloon can be negative, but it isn't true in this question by the constraint. So I just have to take the larger numbers as possible, and it makes a larger number of coins. So that's something I can take care, or I should say, yeah, I can have as the observation. But this cannot happen. Good. Okay, let's think of this question with some examples. So I will use an example written in the question statement. So let's say, and I will follow the order which is explained by the explanation here. So firstly, I will choose 1, then 5, 3, 8. 1, 5, 3, 8. Okay. So I get this here. And I burst this. And then 3, so I burst this. And I burst this. Okay. So when I burst this, I will get 3 times 1 times 5. So it should be 15 points, 15 coins. And here I will get, so I have to notice that this one is already deleted. And when I say the adjacent balloon of 5, it becomes 3 and 8. So it should be 3, 5, 8. Yeah, and 60 coins. Am I correct so far? 3, 5, no, 3, 5, 8. Okay, then now at this moment, this balloon and this balloon aren't anymore. So here, the adjacent number is 1 because there's no balloon on the left hand side, and also 8. So I get 1, 3, 8, which is 24. Good. And finally here, because all the balloons except himself is already bursted. So in the end, I will get 1 times 8 times 1, which is 8. Yep. Then in total, I get, so 167 coins. Good. Okay, so this is how I can calculate the coins. And according to the answer explanation, this is the largest number of coins I can get. Not pretty sure for me, but I have to think how I can optimize that. I mean, obviously, I have to think how I can maximize the number of coins. Okay. So let me think from the brute force approach. Obviously, the brute force approach is that I will try every possible permutation and calculate the number of coins I will get. Then I will return the maximum one. Yeah. So there should be n factorial permutation. So for time complexity, there n factorial combination, and to find the adjacent number, I actually cannot find it in the constant time as long as I use the array because I have to shift or just okay, there are two approaches. Number one, I will shift element every time the number is I mean the burst is sorry, the balloon is bursted. In that case, every time, every step, it takes overwhelm time, linear time to shift the numbers, and then I can find the adjacent number in the constant time. Yeah. Or number two, I just mutate the array nums and swap, or I should say replace the number with none. And when I try to find the next, adjacent number from specific cell, I will iterate until I find the non-null number. In that case, yeah, the same rate takes n factorial times n. And but there is one way I can optimize this more. With the linked list, the time complexity should be O of n factorial. I don't need times n. Firstly, I built the maybe double linked list. And every time I try to burst the balloon, I remove the node from the double linked list. And in that way, I can find the adjacent node by just looking at the pointers in the constant time. Yeah, that's another approach. Good. But actually, in this question, I will use the dynamic programming. Yeah, I chose almost the answer first. And I would think how I can use the dynamic programming here. Obviously, what I can do is I start on the first cell, and there are, currently every number can be the first balloon to be bursted. So there are, 4 patterns. And for each, say I burst one first, the remaining numbers are 3, 5, 8. And again, I will think how many numbers I will get from the 3, 5, 8. Yeah. Then maybe I will burst 5 again. In that case, the remaining is 3, 8. So I will just visualize that. So max coins is equal to maximum of the first case. Choose 3 first. In that case, the point is 1, 3, 1. So, but I don't write it now. Oh, I will just write it on my second thought. Sorry. So, max coins I can get from 3158 is this is the maximum of the case I choose 3 first. So 3 times 1 times 3 times 1 plus number of coins I will get from 158. And when I choose the number 1 first, I will get 3 times 1 times 5. Then the number of coins I will get from in the future. So it should be 315. 1 is the radius, so 358. Okay, so now obviously what I'm doing is the recursion. Yes, I'm doing the solving this. I'm solving this question recursively, and also I can use the memorization. So Oh, it's so heavy. Okay. S- s- Wait a minute. Okay. So I'm using the recursion and also I can use the memorization because, for example, oh, um, the case when I choose 3 first, then 1, in that case, remaining balloons are 5 and 8. And the other pattern, like I choose 1 first, then 3 is next, then remaining numbers are 5 and 8. In either way, the number of coins I can get from 5A are the same. So that's why I will do the recursion, memorization. I will just save how many coins I will get from 5, 8 nums array in the cache. Then I can reuse that. In that way, I can reduce the redundant work. Okay. So let's think of the time complexity. So in this approach, the argument of the recursive function should be the state. Is the nums array. I can think of this as the state of the remaining balloons. I will write the interface first. Wait a minute. So it's really unresponsible. So let me stop my video. Okay. So sorry. So the recursive functions interface is like this. Max coins. I will get the nums array, and I will return the max coins. Yeah. So I would say, let's think how this nums array can be. And I will think of this nums array as the remaining number, the state of the remaining balloons and how it can be. So that's my first thing I would like to think. Yeah. So what I'm trying to do is basically, I'm trying to do the complexity analysis here, especially with the time complexity. And for that, I will think of it. So obviously, this nums array can be any subsequence of this 3158 array. And when I think of the subsequence, I have two choices for each element. So I include it in the subsequence or I don't include it. So for example, if I decide to include, not include, it becomes 318. And if I choose to do something like yes, 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 no, no, it becomes like this, only that. So in this way, I can create the subsequence. And I have two choices for each element. And there are n choices. So in total, it should be 2 to the power of n subsequences. And this is exactly equal to the number of state this argument nums can take. I can say for this one, there are 2 to the power of n state. And let me think, how much time does it take to calculate the number of coins I can get from the nums array? So assuming that there are n coins remaining, let's think I get array like this. I will think of three cases: bursting this first, or bursting this first, or bursting this first. And for each, I will call the recursion. So again, it should be like this. Yeah. And I will compare them. This or this or 213, sorry, 211 max remaining 32. Yeah, this. So for each, it will take some time, and there are n iteration steps up to n. So this depends on the number of elements remaining, or just included in the nums. But in the upper bound, it can take there are n elements. And for each, I don't know how much this take, but basically, aside from calculating this, it's constant time. Okay. So that being said, in total, I will think how much time is it? And actually saying the answer first, the time complexity becomes 2 to the power of n times n. Because, okay, from here, it becomes interesting. So I will think, for example, in this case, here, yes, I have to calculate this. But once this is calculated, this calculation takes only the constant time, because I have to just take it from the cache. Same for this. Once I calculate the 3.1, max 3.1, for the first time, it takes some time to calculate this. But after that, it takes only the constant time to just fetch the result from the cache. Yeah. So that being said, I can say, when I think of the time complexity of this max 321, I will exclude the time complexity of this max 21, max 31, max 32, because I will think of this time complexity in the differently. So for here, for now, I don't include the time complexity it will take for max 21, but instead I will calculate it here and add it here later. So I will do that like this. Okay, so that being said, when I, kind of exclude another recursive function call I will make in this outer, recursive function call, it will take overwhelm time. Just think that this takes a constant time, constant time, constant time. So it will take overwhelm time to calculate each of these, recursive function. Yeah, and that being said, as I said, there are 2 to the power of n subsequences. So basically, I have 2 to the power of n rows for this max something is over n, max something is over n. So in total, the time complexity should be 2 to the power of n times n. Yeah. So this is the time complexity. So this is a quite important idea. I can think of the time complexity of the dynamic programming. So again, I will say the time complexity can be calculated as especially top-down DB time, number of variations, state of arcs, times time complexity, which it will take for each recursive function call, yeah, like this. Okay, so this is a very important idea. Okay, so even though 2 to the power of n times n is quite too much time, and definitely it will TLE because n is now 300. Yeah, 2 to the power of 300 is terribly large, but I will just implement it just just for the explanation because I will implement it here, and you will have the more solid and concrete image of this solution, and then with that, the optimization would be much easier to understand. I will try to implement it first. Okay. So again, as I said, I've written the interface here, so I will use this. So this nums has to be the tuple, not the list. Yeah. So anyway, when I get the max coins, and yes, I will use it in the main method. Like this. Then here, if there is only one coin, that's the base case. So I will get the, coin with that bursting the balloon, and I have no more balloon to be bursted. Yeah, this is it. And aside from that, there are one or more remaining balloons. I will think each balloon I should burst. Then for each case, I will calculate the number of total coins I will get, and then return the maximum one. So I would say this is burst index. Yeah. So number of coin I will get from bursting this coin, bursting this balloon is yeah, this one. But I just have to take care that this I, burst I, can be 0 or last index. In that case, this or this should be treated as 1. Okay, so let's say left num and right num. Okay, now we get rest num right num. Yep. So this is how I guess calculates the number of coins by bursting one of the balloon. And in that case, the remaining balloons is something like this. So, yep. I will take a look at each num in the given array nums, and only for index is equal to burst I will skip it because it already bursted. And then, aside from that, I will take a look at num and put them into the array, and now I get rim nums. And obviously, I have to make it a tuple. Yep. And from here, I will call the recursive function. And coin, and this is coins I will get from bursting this, and maybe I say future coins. So yep, remaining nums, and I get future coins. So total coin should be coin plus future coins, and I will update the rate by this. And return it in the end. Okay. So yeah, for example, if I think of the coin 321, first three, I will call the maximum nums with 321 tuple. Yep. This argument nums cannot be erased when I try to cache it. I didn't explain the reason here, but simply saying this cache is like the key value pair, and for key, the key value versus the key should not be changed. For example, if I use the list like this, if this is the key value pair, later I can append some new element here. Yeah. And in that case, this key value pair is yeah, actually updated. And that's what we'd want to do to avoid the bugs. So the Python decided that for HashMap, it should not be mutated, and tuple in Python can be mutated. So I can use the tuple, but I can't use the rest. With that being said, firstly I code this with 321. And this is not length num length not is not equal to 1. So this is not the base case. I go to line 78 and the return is now negative infinity. And here in line 79, I will traverse each of index 0 and 1 and 2. And in the case of index 0, what I will get is left num 1, yes, and right num is this, which is index 1. So it should be 2. Okay, so this should be 1, this should be 2. So this should be 1 times 3 times 2. So far as expected, because I get 1, 3, 2, the first 3 coins. Yep. And remaining nums is, I do the calculation here. So nums was 3, 2, 1. And I will skip burst index 0 case. So I skip this and I get 2-1 topper here. Yeah. And now future coins is max coins with 2-1. Yes, this is totally as expected because 2-1 are remaining coins. And the total coin should be, I don't dry run anymore, but total coin is the sum of the current coin and the future coins. And I update the read with the total coin. And finally, I will return the read. And that return value should be returned from the main method. In this case, max coins method. Good. So totally as expected. I'm quite confident in my code. So let me execute it. Okay, I need self dot. So it should be range. Okay, no, this should be burst I. Aside from this, burst I is, yep. Okay, good. And I submit it. And it should be time limit exceeded. Yes, time limit exceeded. Okay, so I have to optimize this. Good.